it seems pretty mysterious when they mention unseen software engineering efforts. What does this mean in the context of Google's SRE teams?
It's all about the behind-the-scenes magic. Most people know Google for its popular products like Gmail or Maps, but there's a whole world of software engineering happening that isn't as visible.
So what exactly do these site reliability engineering teams do that remains unseen?
The SRE teams are like the unsung heroes, EA. They create internal tools specifically designed to keep Google's vast production system reliable. Their work is essential for maintaining uptime and reducing latency, ensuring everything runs smoothly.
If they're focusing on uptime and latency, wouldn't they need to have a vast understanding of Google's production environment?
Exactly. Google's production environment is incredibly complex, one of the most intricate machines ever built, you could say. SREs have an intimate familiarity with it, which is why they're perfectly positioned to develop the right tools and solutions.
And when they talk about having a product-based mindset, what is that all about? Does it mean they approach their tool development differently?
Yes, indeed. They treat each tool like its own product. This means they think about the long-term roadmap, consider their internal customers, who are other engineers, and focus on creating full-fledged software projects, rather than just quick fixes.
That sounds like a strategic approach. How do these tools fit into the broader scope of their work?
These tools are central, EI. They tackle internal problems and handle specific use cases that are vital for keeping the massive scale of Google's operations up and running. They're essential for optimizing how Google functionally operates at such an enormous scale.
What happens to these tools once they're developed? Are they shared with other teams within Google?
Oh, definitely. Once a tool proves itself, it becomes a critical part of the infrastructure, shared and improved upon across various teams. It's a sort of internal ecosystem where innovations grow and improve in effectiveness over time.
Are these tools only for the benefit of the production environment, or do they provide other advantages, too?
Great question. While they're primarily about ensuring the reliability and efficiency of Google's systems, they also serve to empower the engineers. It's about providing robust solutions that help others work smarter.
I see. It seems like such a dynamic environment. How do the SRE teams keep up with the rapid advancements and changes in technology?
It's all part of their adaptability. They keep innovating. The teams always look for new ways to streamline processes, automate tasks, and develop tools that minimize disruptions while keeping pace with technological advances.
Does this mean the SRE teams continuously evolve their tools, or do they start fresh every time a new challenge arises?
A bit of both, They iterate on existing tools to keep up with changing demands, but they aren't afraid to start from scratch if necessary for tackling entirely new challenges. It's this flexibility that keeps them ahead of the curve.
It sounds highly collaborative. How involved are other departments or fields of expertise within Google in these engineering efforts?
Very much so. They often pull in experts from various fields to refine and perfect their tools. It's a blending of multiple perspectives that leads to more innovative solutions and prevents operations from having tunnel vision.
Do you think this methodology of focusing on internal tool development will be a trend other companies might adopt?
Absolutely. Many are already realizing how critical it is to build in-house expertise and solutions finely tuned to their unique operational wrinkles. It's a logical step forward for any company at scale.
And what are some specific tools or techniques that these SREs use in their development efforts?
I'd have to delve into specifics like binary rollout mechanisms, dynamic server compositions, and the monitoring frameworks they craft. Each tool is highly specialized for managing resources efficiently and addressing particular needs.
Do these tools influence the engineering culture at Google too?
Without a doubt, they cultivate a culture of resilience and innovation, fundamentally shaping the way engineers approach problem solving. There's a spirit of being proactive rather than reactive.
It's fascinating how this hidden world of engineering supports and sustains such a massive operation. There's so much more than what meets the eye.
Totally. It's like peeking into the clockworks of a giant, complex timepiece. There's beauty and brilliance in every gear and alignment.
I imagine there's a sense of satisfaction that comes from knowing how these tools impact Google's overall success.
Very much so. For SREs, seeing their creations make a tangible difference in such a critical environment is incredibly rewarding. It's both an art and a science in action.
Hu Tao, I find it quite intriguing how software engineering is viewed as critical within SRE at Google. Could you elaborate on why that's the case?
Certainly. So software engineering is a big deal within SRE because these engineers have a very special understanding of Google's massive production scale.
Does that mean they have insights that other teams might not?
Exactly. They have first-hand experience and unique insights into the nitty-gritty details of Google's prod scale. This allows them to create tools that are just perfect for keeping things running smoothly.
And it's not just about maintaining uptime and reducing latency, is it?
Nope, it's not just that. It's also about bringing benefits to the engineers themselves, like career growth opportunities and balancing their work between software and system operations.
Balancing work between those two worlds sounds tricky. How do they manage that?
Yeah, it can be challenging, but having a mix of both worlds helps them keep their coding skills sharp while still managing the systems effectively.
That sounds ideal for engineers who want diverse challenges. Does this approach contribute to job satisfaction too?
Oh, for sure. Being able to engage in long-term projects and turn their ideas into solid products brings a lot of fulfillment.
Is there a particular advantage for Google itself with this engineering focus in SRE?
Absolutely. For Google, having SREs with this focused engineering mindset ensures that the tools they develop are finely tuned to fit Google's exact needs.
Do they rely much on third-party tools at all, or is everything in-house?
They mainly develop in-house because third-party tools often aren't designed to operate at Google's enormous scale. It's like needing tailor-fit clothes instead of off-the-rack suits.
It seems the expertise of SREs really drives the software development forward. Are there any other benefits to the engineers themselves?
Definitely. Working on internal software development projects also offers them the chance to diversify their skills and explore different problem-solving approaches.
It must be quite rewarding to see personal growth and contribute to something so impactful at Google.
Exactly. It's a pretty dynamic environment, and that's a big motivator for many engineers to stay engaged and continuously improve.
Are there ever challenges related to being deeply embedded in the subject matter?
Well, being so enmeshed certainly makes it easier to grasp what the tools need to accomplish, but it can also mean they have to constantly adapt to changing needs and environments.
I guess their deep knowledge also supports quicker iteration and better user feedback, right?
You got it. Being so close to the intended users, other SREs, they get honest, direct feedback which helps them improve tools rapidly.
Speaking of feedback, how do they manage user expectations with internal releases?
They generally get more understanding from internal users about minimal UIs and early versions, which helps start the iteration process much earlier.
I imagine having this direct relationship with users is both beneficial and daunting.
Absolutely. It's a double-edged sword sometimes, but it mostly means they can quickly launch tools and refine them based on authentic needs.
With so much innovation daily, how do SREs ensure they don't just scale their teams with service growth?
Great question. They focus heavily on automation to ensure they can support exponential service growth without needing to grow the team at the same rate.
That's crucial, especially given the size of Google's operations. Does this efficiency lessen the workload for engineers themselves?
It definitely helps. By lightening the load with automation and robust toolsets, they can engage more in projects that enhance job satisfaction.
So it's a win-win for both SREs and Google.
Indeed. It's all about creating a balanced environment where engineers can thrive, while keeping Google's enormous systems humming perfectly.
In such a vibrant setting, is diversity within the teams also emphasized?
For sure they strive for diversity. Mixing traditional software developers and systems engineers brings a variety of perspectives, which is vital for avoiding blind spots.
It's impressive how they weave together so many elements. Does this setup also attract engineers with diverse skill sets?
Absolutely, The approach broadens Google's appeal to engineers eager to work on challenging and diverse projects.
Sounds like there's a lot to learn just within the realm of SRE software engineering.
There really is. It's like a treasure trove of experiences and knowledge, just waiting for engineers to dive in and make their mark.
It's fascinating how this approach enriches both individual and organizational growth. I bet there's more to explore around. Hu Tao, what exactly is traditional capacity planning, and why is it considered so challenging?
Traditional capacity planning is like trying to balance on a tightrope while juggling. It involves predicting how many resources Google will need in the future, but because of its sheer scale, even minor changes can throw everything off.
Why are these minor changes so impactful? Don't they have contingencies in place?
Well, each change has a ripple effect. Imagine you plan for a certain amount of resources, but suddenly a service requires more due to unforeseen demand spikes. Now the entire resource allocation needs revisiting, and that can affect other services too.
That sounds rather brittle. Isn't there a way to build flexibility into these plans?
Traditionally, it's a static process that relies on precise predictions, but real life doesn't always stick to the plan. If efficiency drops or adoption rates soar unexpectedly, you're in for a roller coaster.
So, what do they do when plans need changing? Is it a quick fix, or are we talking major overhauls?
Mostly, it requires a lot of manual adjustments. Sometimes plans have to be completely recreated because even a small slip or change demands a full cross-check against the original allocation.
That sounds incredibly labor-intensive. Why is such a manual process still common practice?
Tradition. Mainly. It's been the standard way for a long time, driven by demand forecasts that have to cover long periods. The problem is things don't usually go as smoothly as drawn out on the spreadsheets.
Spreadsheets? Aren't those a bit outdated for managing such vast resources?
Oh, they are. Spreadsheets aren't equipped to handle Google's scale. They're prone to errors, aren't scalable, and data quickly becomes stale, making it all rather cumbersome.
I find it puzzling. Are there no better tools for this type of planning?
Well, the tools used are typically unreliable, or too cumbersome, where manual interventions are often necessary, like playing a game of bin packing with a million pieces.
Bin packing? That sounds like something a human wouldn't want to tackle manually.
Exactly, and manually computed bin packing is an NP-hard problem, notorious for being extremely complex and tedious, especially on this scale.
Does that mean they sometimes have to simplify down requirements to make do with the resources?
Yes, exactly. And that often leads to imprecise and inefficient use of resources. Service owners might have to compromise on their true requirements just to make it work.
I can see how that can lead to inefficiencies. How do they decide which requirements to prioritize or sacrifice?
Prioritization becomes crucial. They have to weigh the importance of different service requirements, which can be tricky when resources fall short of demand.
It feels like a constant balancing act then. How do they manage when unexpected changes occur, like a delivery delay for new resources?
Each change, even minor ones, forces a review of the entire allocation plan. A delay could mean shuffling resources to maintain demands elsewhere, which is no small task.
I imagine it must be daunting to face revisions again and again. What about a plan's longevity? Is it recurrently reassessed?
Perpetually. Plans are in a constant state of revision as assumptions change, and every change has cascading effects. It's like trying to hit a moving target.
It seems exhausting to continually adjust without a clear resolution. What's the biggest challenge you'd say they face?
Well, it's largely about maintaining precision in the face of an ever-changing demand landscape, while the process itself is brittle and time-consuming.
How does this affect Google's broader operations or goals? If the planning is this temperamental, I imagine it impacts other areas too.
Indeed, constant recalibration can cause delays and inefficiencies, detracting from Google's operational agility and speed, which are vital at such scale.
With all these challenges, are there any benefits, or is it all just a burden to bear?
Interestingly, the challenge drives innovation. Engineers are continuously seeking better ways, leading to the development of more refined tools and approaches.
That's reassuring to hear. Is that where innovative approaches like intent-based planning come into play, to alleviate these challenges?
Spot on. Intent-based planning is precisely designed to address these inefficiencies by focusing on what services truly need and creating plans that can adapt more fluidly to change.
So, does this mean we're moving away from traditional methods entirely?
Not entirely, but there's definitely a shift towards more dynamic, intent-driven methodologies, reducing the brittleness of traditional plans and paving the way for more flexible solutions.
And that's presumably where tools like Auxon come into play, offering some relief from the manual drudgery?
Exactly. Auxon automates the whole capacity planning, making it more adaptive and less dependent on those fickle manual processes.
It's like having a companion in the shadows doing the heavy lifting for you. What drives Google's choice in moving towards these solutions?
Efficiency and precision, EI. Google thrives on both these elements, and overcoming traditional limits enables them to hit these benchmarks better.
So for now, traditional methods are being phased out in favor of innovation. Yet the journey to seamless capacity planning is ongoing.
Indeed, they're continually evolving practices and tools, always looking for the next breakthrough. A never-ending adventure.
Incredible. I can see how this never-ending cycle of adjustment is both a challenge and an opportunity for continuous growth. Perhaps one day with fewer headaches?
One can hope. After all, refining the art of planning is like improving a recipe over time, one iteration at a time.
Hu Tao, I've heard you mention Google's intent-based capacity planning. What exactly does that entail?
It's quite a revolutionary approach. Instead of manually predicting how much resource to allocate, Google uses intent-based capacity planning to encode service needs and automate resource distribution.
How does that differ from traditional capacity planning?
Traditional planning is all manual, adjusting resources like a tightrope walker juggling eggs, one misstep, and it all falls apart. Intent-based planning, however, captures true service requirements, allowing for flexibility and adaptability.
So intention plays a key role. How does it actually work in practice?
It's all about setting clear intentions or requirements for services like wanting N+2 redundancy or having certain performance metrics. Then, these are encoded into a system.
And that's where Auxon comes into play.
Exactly, Auxon is Google's tool that embodies this intent-based capacity planning. It gathers all these encoded requirements and generates an allocation plan for resources.
That sounds like a significant burden off engineers. How does it handle the diverse requirements?
Auxon uses a sophisticated configuration language to translate human intent into machine-readable instructions, figuring out where and how resources need to be allocated.
Does it allow for prioritization of these requirements?
Absolutely. If resources are limited, Auxon can prioritize based on service needs, ensuring critical services get what they require first.
This must vastly improve efficiency. How does Auxon solve such complex problems?
Behind the scenes, Auxon uses a solver to handle the math and logic, running calculations that even include solving mixed integer linear programs. It's rather impressive tackling what humans find nearly impossible manually.
But with automation like this, do human engineers still play a role?
Definitely. Engineers set up the configurations, monitor performance, and make adjustments as needed. Auxon is more of a tool to lighten their workload and focus on higher priorities.
It must have a huge impact on Google's infrastructure efficiency.
Indeed, it does. Auxon optimizes how resources are used, translating to cost savings and reducing the unnecessary toil for engineers.
Is this process all automated, or is there room for iterative improvements?
There's always room for iteration. Google is big on launch and iterate, gradually improving methods and capabilities over time. Auxon's design allows for enhancements without starting from scratch.
So even a seemingly complex system needs to adapt and evolve.
Exactly. It's crucial. as service demands and available resources change constantly. Keeping Auxon flexible allows Google to remain resilient to these changes.
Are there any components of Auxon that are particularly crucial in its functionality?
Oh, certainly. Key components include performance data, demand forecast data, resource supply, and of course, the brain of the tool, Auxon Solver and its configuration language engine.
Could you tell me more about the brain you mentioned? The solver?
The solver handles the heavy lifting, processing all inputs to create a coherent allocation plan that aligns with the described intents. Think of it like a master puzzle solver.
Does this system face challenges when new changes come into play?
Of course, each change in demand or availability challenges it to readjust, but because it's automated, those adjustments are less of a headache over manual tweaks.
And does it ever encounter issues when dealing with very specific requirements?
There can be tricky bits, but Auxon is designed with the capacity to handle specifics. It might not solve everything perfectly, but it iterates to get closer to the ideal solution over time.
Talking about solving challenges, are there significant lessons learned from implementing a tool like this?
Definitely. Key lessons include embracing iteration over seeking perfection and allowing for modularity, so that different systems can plug in without force-fitting into one rigid structure.
I see how Auxon embodies both precision and adaptability. Is there a way they continually improve upon it?
They collect feedback not just from the tool's performance, but from direct user experiences, effectively capitalizing on the close relationship between SREs and Google's production systems.
It's fascinating how this tool not only optimizes resources, but also directs growth for SREs working with it.
Spot on, It truly exemplifies a symbiotic growth benefiting both the software systems and those who helm it, pushing the boundaries of what's possible.
It sounds like such an evolved approach to managing resources at scale. Quite inspiring indeed.
And it's just the beginning, really. As scaling needs further evolve, so too can the strategies and tools like Auxon, always a work in progress, moving towards even greater efficiency.
Thank you, Hu Tao, for painting such a vivid picture of intent-based capacity planning. It gives much hope for future advancements.
Glad to share, just like poetry in motion, right? Who knows what fascinating tools tomorrow's insights will bring?